is the sixth part of the session where I will tell you how to create scripts to install Docker, Minikube, kubectl, SonarQube, Trivy, and Terrascan using Backscript in GitHub Actions pipeline. So we have already discussed about running scripts in a GitHub Actions pipeline in the previous session. So now we will be deep dive into various scripts that we are installing into the EC2 instance, where our Spring Boot application will be running. So first, we will be installing Docker to build our images for a Spring Boot application. Then we will be installing SonarQube to do code quality checks. After that, we will be installing Trivy and Terrascan to scan Docker images and Kubernetes YAML file. And lastly, we will be installing kubectl and Minikube to control Kubernetes cluster using CLI commands and even deploy our Spring Boot application. So let's get a brief about these tools that we are using in this project. So Docker is a containerization platform that allows developers to package their application and dependencies into light and portable containers, as you can see here. This makes it easy to deploy and run application on any system that supports the Docker. The second tool is Minikube. So Minikube is a tool that allows you to run a single node Kubernetes cluster locally on your development machine. This is useful for testing and developing Kubernetes-based application without the need of full-fledged cluster. The third tool is kubectl. So kubectl is a command line tool for controlling Kubernetes cluster. It allows you to deploy, inspect, and manage your application on a Kubernetes cluster. You can use kubectl to create, update, and delete resources such as pods, services, and deployments. So the fourth tool is SonarQube. So SonarQube is an open source platform for continuous inspection of code quality. It provides a wide range of code analysis tools, include static code analysis, unit testing, and code coverage. So the fifth tool is Trivy. So Trivy is very helpful. It scans vulnerabilities in a wide range of package formats. It basically scans vulnerabilities in a Docker image, any image, including Alpine, Debian, any package formats like Alpine, Debian, Ubuntu, Red Hat, as well as container images in Docker, OCI, and JSON formats. It supports multiple languages such as Go, Java, Node.js, Ruby, and Python. And it can scan for vulnerabilities in both the operating system and application. So the last tool that we are using is Terrascan. So Terrascan can scan for vulnerabilities in Terraform and CloudFormation files. And it uses a rule-based engine to detect and report on security risks and compliance issues such as misconfiguration, insecure settings, and exposed secrets. The rule base is continuously updated by the community and the team. It can be run as a CLI tool and it can be integrated with various CI/CD tools. Like in our case, we are integrating it with the GitHub Actions. It can be integrated with various other CI/CD tools such as Jenkins and even container orchestration tools like Kubernetes. So you can see the report of the Terrascan that we will get after scanning the Kubernetes YAML file. So in the DevOps session 5 session, we have seen that the Kubernetes instance has been created by Terraform. And in that EC2 instance, we have installed the previous 6 rigs. So let's discuss the script one by one. So this is the script where we are first installing the Docker. So this script is checking if the Docker is already installed on the system by the command systemctl status docker.service. So it is checking whether the Docker service is already running or not. So if it is running, then it is printing that Docker is installed successfully and even printing the Docker version. But if it is not installed, then it will simply install the Docker container a Docker package by using these commands, which are written in the slide, and it updates the packages and install the necessary dependencies. After that, this is the whole script which is written. So the next script which we are now seeing is we are installing the SonarQube. So here, this line shows that it is a bash script, and a variable is assigned like container name SonarQube. So this is a variable where we are putting a value like SonarQube. Now, what happens is like that. So the third line, which is written in the if clause, is to check whether the running status of the container with the name specified in the container name. So it is not running. So it is checking that whether the SonarQube container is running or not. If it is not running, then what will it do? It's like it will take the SonarQube image and it will run the SonarQube container in the port 9000. While if it is running already, then it will do, it will start the container if it is exited, and it will print SonarQube is running successfully. So let's check the third kubectl script. So this script is used to check if the Kubernetes command tool kubectl is installed and the correct version on the system. So the script starts by running the kubectl version client dev and redirecting it. It is redirecting the output to the dev null. So the exit code of the command is stored in the variable $. If the command returns an exit code of 0, then it means kubectl is installed and the script will run kubectl is installed, followed by the kubectl version. If it is not installed, then the script proceeds to download the latest version of kubectl and then does the checksum of the kubectl. And by using all these commands, it is installing the kubectl, and lastly, it is printing the kubectl version. So let's go to the fourth script, which is this is the script for installing Minikube. So again, the script starts with bin bash, which it tells the system that the script should be executed by the command interpreter at the path bin bash. So then the second line is Minikube version and dev is. So this is used to check the version of the Minikube installed on the system. The output of the command is redirected to the dev null. So this is done to suppress the output of the command, as we only need the exit status of the command. So the next line here, what it does is like it checks the exit status of the previous command, which is stored in there. And if it is equal to 0, it means that the Minikube is already installed and even the Minikube version is printed. And if not, then in the else clause, it is installing the Minikube and even starting the Minikube by using this Minikube start command. So then the fifth script that we have installed is Trivy script. It is installing Trivy. The script checks if the Trivy vulnerability scanner is installed on the system or not by using command -me Trivy. So what is happening is like if it is not installed, then it is showing that Trivy is not installed, and first it will check whether what is the Trivy version, and if nothing is printed, then Trivy would be installed by using these commands, and if not, then it will print Trivy is installed. And the last script is Terrascan script. So this in the Terrascan script is the same thing. Here what we are doing is like first checking whether Terrascan is installed or not by using the command -v. It will print the Terraform version, and if the Terraform version is not printed, then it will print Terraform is not installed, and it will install the Terraform and write write Terrascan. And if it is installed, if it is installed, then it can go into the else clause and just write Terrascan is installed. So these are the scripts that we have deployed in the EC2 instance, which was created by the Terraform. So this is all for the sixth part of the session. Thank you all.